So we're still talking about the same company. We're still looking at maximizing profit in this particular problem. But what's changing is that now a tax has been imposed on the product we're producing. And in addition to our other costs, we're now going to be charged $20 per shredder as this government tax. So we want to, again, start off by establishing the function that we're going to be maximizing or minimizing. In this case, we're after our weekly profit, but our cost equation has changed. So we'll start off by setting up this cost equation, which is going to be the original cost equation that we had in the last example, plus now this tax that we're adding on. So that'll be 90,000 plus 30x, which was the original cost equation, and now we're adding on this additional $20 per shredder. So our cost equation is now 90,000 plus 50x. This means that our profit function, which is still going to be revenue minus cost, is 300x minus x squared over 30 minus 90,000 plus 50x, or minus that quantity 90,000 plus 50x. So combining our like terms, we'll end up with the simplified expression negative x squared over 30 plus 250x minus 5,000, or I'm sorry, minus 90,000. So we've established the function. We can establish the domain, which again is still just carrying over from the original match problem 3. So our demand is still bounded between 0 and 10,000. So we can go ahead and establish the problem that we're actually trying to answer. So in this case, that is to maximize our profit function on the interval from 0 to 10,000, or when x is bounded between 0 and 10,000. So now that we know the problem that we're trying to solve, we can find critical values. So the derivative of our profit function will be negative x over 15 plus 250. Setting that equal to 0 will give us x equals 3,750 as our critical value. We'll then apply the second derivative test. The second derivative is going to be negative 1 over 15, which again is less than or equal to 0 for all x, which implies that p of 3,750 is our absolute maximum. And again, the last step is to take all this mathematical information and answer the questions that are being posed. So our profit at a production level of 3,750 will be $463,750. And when x equals 3,750, we know that our price point, again going back to that price demand equation from match problem 3, will be 300 minus 3,750 divided by 3, or $175. So the question is, or the questions are, how many shredders should we produce to maximize our weekly profit? What is that weekly profit? How much should we charge per shredder in order to realize that maximum profit? So we should manufacture 3,750 shredders to achieve the maximum profit of, so manufacturing 3,750 shredders to achieve a maximum profit of $463,750 and charging $175 per shredder.